My name is Cheren. I'm a software engineer at Wolfram Research, and
I'm
I'm presenting
Robert
here with,
Robert Collier. I'm also a software engineer here at Wolfram Research.
and let's dive right in. So you've already seen the abstract. We want to talk today about some new features as well as some cool applications that I think that people are going to be excited about with the updates coming to import and export. So just to give a quick summary of what we're going to talk about, we have some brand new formats. Zstandard, which is the new compression algorithm developed by Facebook. Onyx export, we had import before, and now you're able to take your neural net objects and export those to Onyx. We have PEM import for working with different cryptography objects, and a number of updated formats. In particular, there's a huge update to PDF coming in the next version that completely overhauls import. We've obsoleted Ogvorbis M4A and SWF. Ogvorbis and M4A are still available under the new formats, MP4 and OGG. There are some updates to video formats generally. Package was renamed to WL, and dataset export now works in XLSX. There's some DICOM updates, some image updates, and then we're going to talk about some other things that my team has been working on, specifically related to URL support and import related functions, as well as some updates to file format. Let's jump right into Zstandard. So with Zstandard, the big push to get this to the system is that it has notably better compression and notably faster compression times. So if we just grab here the Declaration of Independence and repeat it about 10,000 times, that gives us a good example for something that's easily compressible. The original size of this file was 90 megabytes, and after a quick export, we were able to get that all the way down to 12 kilobytes. That's a tremendous improvement. And you'll even notice that this works both with export and create archive. The cool thing about Zstandard is the fast timing and the really good compression ratios. You'll notice that it has a smaller file size than gzip in less time. Onyx export has been added. Oh, sorry, I forgot to say one thing about Zstandard. Zstandard is also hooked up under the hood. You may have noticed that when you import things that are gzip compressed, it kind of takes care of that automatically and then gets to the content underneath. You'll see the same thing with Zstandard. It's hooked up across the system the same way that gzip and bzip2 are. So jumping into just a simple Onyx import, we can grab a net graph or even just a specific layer of a graph from an Onyx file. So say that you have some net graph that you generate here, and you want to preserve that so that you can use it in future sessions. Onyx is a great format for exporting this data. Here you can see that we exported a graph as well as a single layer. You can also control metadata in the Onyx file using options to export. And as you can see, this is a fairly faithful reproduction of the net graph that we originally put in when we import it from that file. PEM import is another new format. PEM files look like this. They have some comments saying which chunk of data you're about to receive, and then just some data. This is a private key. PEM files contain things like private keys, public keys, and security certificates. So we have a private key here, and we have a public key. And with that, we're able to generate a digital signature from the private key that anybody with the public key can verify. The biggest thing that I want to talk about today is the many enhancements to PDF import. So one thing I have to note, unfortunately, I missed the build by just one day with the Packlet for PDF tools. If you're following along and the notebook is already uploaded on Pathable, you're going to have to run this to fix the conference builds. Of course, everything will work out of the box once 12.2 is released. Let's go ahead and download a couple of PDF files that I found online. Yes, PEM does support multiple keys within the same file. Okay, so If we just take a look at the elements list, this has grown quite a bit. There are several new elements ranging from metadata to annotation type data like highlighted text and URLs. So you can extract more data from the PDFs themselves, in addition to a complete overhaul on getting back images and also getting back plain text. So let's just start by mentioning that the default element for import a PDF has changed. The default element is now page images. And what page images gives you is images of each page. These are no longer graphics objects. The huge upside to this is that these images are absolutely faithful and robust renders of these images. So if you really want to get an accurate depiction of what the page looks like, this is going to work perfectly for you now. You can grab a single page efficiently from a PDF document, and you can control its image resolution. This is particularly important if you've seen my previous talks for doing some kind of OCR. If you have a really high resolution, you're going to get much more faithful recognition when using functions like text recognize. You can also see that it's quite zippy. We can get the timing right here, and it's very quick to get all of the plain text from this file. You can grab the plain text for just a particular page, and again, that's efficient. You can even get formatted text that takes styling elements directly from the document and applies them to the page. You can get hyperlinks now that actually come back as hyperlinks so that you can see the display text in addition to the link underneath. And we have URL support. So if you just want the URLs, you don't care about these things coming back as hyperlinks, you can get those directly too. Embedded images is going to give you back an association of the page number that embedded images were found on and a list of the embedded images on that page. We also have strong metadata support in PDF documents. So if you're trying to do some analysis on where these PDFs are coming from, you can look at things like the creator. Here's where we're getting into some even cooler new stuff. Now, usually with a table of contents, if you're opening it in a PDF viewer, you just want to get some idea of which page do I go to see what's, this section. And what I wanted to do was create something that took that to another level and gave you something that was even more computable. So this returns an actual graph here. And this graph has nodes that depend on the parent that the section is a part of. What is neat about this is you can actually do graph computations using the object that you get back from contents graph. So you can see that there's associations that give them name and IDs, which is essential because the names can be duplicate, and gives you the structure. The kinds of things that you could do with that are go through and get the names, or try to figure out some kind of analysis of the depth from the root of the document. So this bit of code here grabs the graph distance of each vertex in the graph back to the first vertex in the graph. Annotation also has rich support now. So let's grab this PDF document and let's go ahead and start highlighting some text because we want to go through and get very specific pieces of information out later. I can highlight that and let's just save the document. Well, let's draw something on it too. How about a nice big smiley face at the top of the document? So we have a new element called highlighted text that's just going to give you the specific chunks of text that are on each page. So it'll tell you the page number that it found highlighted text and what the text was. Page images by default is going to render all of these things, but you have control over rendered elements in PDF with the rendered elements option. And for my favorite new feature, we have forms. So here is the I-9 form straight from the IRS. This is, for those who aren't in the States, this is a document used by the IRS to determine that you are an eligible employee in the United States. If we just take a look at the form field rules, we have the names of the form fields. So these are set when you create the form document, and the values of them. Right now they're all blank. You can see that it's just a bunch of empty strings. Let's open this file that I just downloaded and go in and put in some information. So let's give it my last name, my first name, and how about a state? I'm from Minnesota, so let's do that. Great. We can save this and take a look at the fields that we've just filled in. So now I'm just taking the form field rules on page 4 and grabbing any string that actually has some data in it. So you can see that I just saved the document, and now we can extract the values as well as the names of the form fields. And you can look up by their names then the values that you want to use in your analysis. I wanted to take this one step further because the first thing that I thought of when I was developing this is how easy it would be to automate getting PDF documents that you distribute and doing some kind of analysis on the responses that you get in those form fields. So let's just start with an idea. We want to make a geographics that drops a pin on the state of everybody who has submitted the form. And there we are. So it drops a pin on Minnesota. And notice how simple this code is. All we have to do is use interpreter to identify what these strings are. So we need somewhere to accumulate all the submissions from people. So we'll make a data bin for that. Right now the data bin's empty, but if we were to just make a simple web request, we can drop some data into our data bin, maybe the state Wisconsin. Now you'll notice that in our data bin we have Wisconsin. I can make a cloud object called data map. And so can you fill the forms programmatically and save the PDF again? You can't do that in Mathematica just yet. So if you want to fill out forms, you're going to need another editor for that. If anybody wants to follow along, I just URL shortened this cloud object link here. And we're going to see that we can actually, now just beef this code up a little bit to extract the values from bin rather than just hard coding in the value Minnesota before. So let's deploy this thing. We're going to take our geographics, deploy it as an exported PNG, and we're going to tell it to update this cloud object every 3 seconds. Let's take a look at what we get. All right, we have an image, it's dropped the point. Anybody can access this cloud object now. Let's go ahead and drop another piece of data in there, just Arizona. I realize that we haven't done the PDF part yet, but we'll get there. All right, so our bin has Arizona and Wisconsin. If we take a look at this, oh, look, Arizona's already populated. Great. So what I really wanted to show here was this example down here. And I'll run it and show you what it looks like. Upload a PDF file. To create a form page where people can go and submit the results is just, yet again, one line of code that in here contains the importer to extract data from a particular field and then pass that in as data. Since we can't do that, the only reason we can't do that right now is because, well, the cloud isn't running 12.2 and this is going to be deployed as an API function. So what I'm going to do instead to show you how this works is come here, and instead of uploading a PDF file, I'm just going to type in the name of a state. So let's try Texas. Okay, it gets added. Let's see if it shows up on our data bin. Great, there it is. So what I'm trying to show is that you can upload a PDF document, immediately get the values that were filled in from your users, and do some kind of analysis and publish that to a cloud API in just 5 lines of code. One other example I want to show from PDF, this was already shown in Stephen's keynote. Just in the past week, Michael Trott has put together this wonderful example showing a list of sightings of Mathematica being used in the wild in various scientific papers. And using the new importer, he was able to get all this information, and you can click on these things and dive into what those papers talk about. So, video codecs. We've improved the selection of best available encoders, so it should work out of the box whatever platform you're on and whether or not you have system FFmpeg. We have also wanted to emphasize that if you go to the tutorial importing and exporting video, you can actually download FFmpeg and hook it up to our system so that you can use the full range of codecs that we aren't able to ship due to various patents. So obsolete formats are OGVorbis, M4A, and SWF. SWF just doesn't exist in the wild anymore. OGVorbis and M4A are being superseded by their video counterparts. So you'll notice that if you call file format on an M4A, you get MP4. These actually get imported as audio objects, not video objects like MP4s do. And export is significantly faster. It took 28 seconds because it had to do some transcoding before. If you're exporting a video now and it's able to do so without making a copy, or sorry, without transcoding and instead using a copy encoder, it's significantly faster. Just a couple of small updates. Package is renamed to WL. These operate the exact same. Package still works if you have that in your code, but we wanted to modernize it to go with our branding. Dataset export works in XLSX. As you can see, I just opened it in Excel, and there's the data for my export. And I'm going to hand it off here to Robert. Let me just quickly answer this question. Can you create a form from a scanned PDF by assuming the square white boxes are text boxes and lines that extend along text baselines are fillable text fields? Well, you wouldn't. So are you saying that you had some paper document that you scanned? Because obviously then there's not going to be form fields in there. If there's form fields, the checkboxes come in as actual binary, or come in as Booleans. If it's a paper document, then you're looking at doing a bunch of OCR and image recognition. Okay, on to Robert.
Okay, just let me share.
I can stop, there we go.
Yep, thank you. We'll just share it all and hope for the best. Okay. Previously, we had DICOM import. We've added, my apologies, let's push that up. We now have a exporter added, and we can do the usual things. Take an image, export it, create an image list because DICOM is a format that can have image lists. Also, like normal, we have named rules for image list and image, and there are others. There's graphics, so you can graphics to graphics list, so you can export cells or other things, but we don't need that for an example here. Probably one of the more interesting examples is the export of meta information, and this is fairly broad. We can specify quite a few things. There are a number of keys that are by default, but as you can see, these are written as we've entered them, including this is a quantity. Let's deal with the Zoom screen. Okay. The more extensive updates, though, are into sort of miscellaneous updates involving the meta information data. We've consolidated everything under one. Previously, we had EXIF and XMP and, for example, IPTC. They're still queryable individually. But they're also queryable now completely under meta information. Some of our examples already have them, and we have extensive information available from. The more extensive thing is they've also been restructured to some extent. These used to be at like document ID used to be at the top level. A few others. They've actually been organized under the different schemas, so that while they're more into the associations a little bit deeper, they're just organized better. Same with just plain XMP. Although plain XMP actually does formatting as opposed to the raw, which just gives you the raw uninterpreted dates and things like that. This is, this used to be along the lines of where for this particular file, there were about 50 EXIF items that were available. We've added support for numerous others. For example, raw height, raw max, and raw width. More interestingly, though, we now push the image resolution into the EXIF data. So we have width, resolution unit. We even add what we hope are reasonable defaults. In 12.1, we added an importer for HAIF or HAIK, depending on which format. This is only out of the box on Mac due to patents, but you can download stuff for Windows. Sorry, Linux at the moment, there isn't available. In this case, I don't have I only have the system MPEG up, so forget the complaint. But some interesting examples, like on Mac OS X, we have a depth image, which this is effectively a height map. Everything that's dark is close. The brighter pixels represent distances that are farther away. And this gives us actually a good example. So we have our image. When we mouse over, we can blur anything that is far away, which sort of, I have kids coming in the background, so it might get a little noisy. My apologies. And we now do EXIF for it, as extensive as our other support. And I keep, okay. More interesting though, we've added URL support through a lot of our functionality. FileFormat, for example, can go out and grab this. It doesn't have a file name associated with it, but from the MIME type, we're able to determine that it's JSON data. Similarly for import, because we can tell from the MIME type that it's JSON, we know how to import it. For me, the most interesting example though is the Create Archive one, where we can include files that are remote in addition to our local ones, and create an archive. And from there, or extract one from over the web. Okay, running long time. So let's speed up. We've previously there were 3 functions that were in import-export context. We've moved them to system, and there are these file format queue, string format queue, and byte array format queue. They allow you to ask the question, is this file of a particular type? And we accept both an alternatives format or a list. Previously, these would not go looking inside of a gzip, but now they do, the same as string format queue and byte array format queue. As part of bringing these into system, we also did a little bit more work in the file format in general for now, and we added a second argument because there were a lot of cases where we saw this type of code. you want to find out what type of file it is, and you have a limited list that you can work with. And this isn't a terribly expensive operation, but if you do it a lot, you might as well save what time you can. And we cut out all the time required to open and close the file, read in the data, and we get to do it at once. If you have nothing, if your file doesn't correspond to any format in your list, we will return none. As part of this, we added string format, byte array format, and also now have a common implementation with FileFormat. So with things like a gzip wrapped GIF, it can detect it, where previously it couldn't look inside at all. The same is true with byte array. Lastly, we have several options. Max items is the only one on this list that is documented in general, so the rest could potentially go away. But the idea is sometimes you have more than one item, more than one format that it matches, so you might want to see which ones they match. If you have a case where it's limited. Now if you note, since it didn't match 2, it only returned the 1. A2 is equivalent, in this case, is equivalent to an up to 2. Similarly, if you have no matches, it will return an empty list. Sometimes there are cases we've found where decoding is something we don't want. So we've added an option that if you just want to look at the top. Now note, this would go through for, if this was just a GIF, this would also pick it up, but it won't look inside a gzip or a bzip. A more interesting case is when you're talking about like something we don't have a strong test for, like JSON. When you just have a string of it, it can't pick it up correctly because we don't have enough information. There's a lot of, for JSON, most of the information we have is in the file name itself. For instance, this one actually looks like a CSV file for all intents and purposes. But we've added an option where you can add a file name and it can then pick it up. Now, this doesn't do away with the other tests. For instance, if you were to suggest it was a JPEG, but it is really a PNG, the PNG wins because of the magic number tabs that we have available. Similarly, with MIME, we can do it with MIME types, although these fall towards the end. These are essentially if we have no data at all left. So we can use the MIME type. But likewise, a PNG would outweigh the MIME type. So that is it for me. I think we're close to actually being done.
Yeah, looks like we had pretty good time there.
Yes, we did.
So I know that the Pathable room is going to be closed in 10 minutes. If people want to stick around and ask us questions for 10 minutes, we'll be here. You can also find us again at the booth tomorrow at 12:30 p.m. Central Time. You can find that on your schedule. If you'd like to join and talk to us, we'll have a half hour there. Otherwise, you can also click on our names in the talk and feel free to schedule a meeting with us or send us a message if you have questions about any of these things that you don't necessarily want to bring to right now or office hours. Does anybody have any questions? You could raise your hand or put it in chat. Otherwise, are there any formats that people are particularly excited to see that we are updating? Are there formats that users want us to start getting to? Looks like we're going to get a question about ZSTD here. I don't think URL fetch decodes Zstandard automatically. That's more in the curl level of stuff. So import will decode ZSTD automatically. URL fetch probably won't. Yeah, I know that it does for gzip. In fact, in order to do all this URL modernization stuff, I actually had to ask Fahim to give me a way to disable that gzip stuff so that I could get the raw contents. So ZSTD probably not. If it can be supported, it's something that's supported through curl. So that would be a separate mechanism. Okay, we have another question here in the Zoom chat asking about tech import. Is there a more specific question? Perhaps I can give somewhat of an overview of where we're at with tech. So we have some basic tech import capabilities. There have been some projects working on improving tech a bit in the company that haven't quite come to fruition yet. We definitely have it on our list of things that we want to provide better support for. And undoubtedly at some point in the future we'll improve on that. All right, well, looks like I'm watching the attendees list drop pretty quickly. So thank you everybody for coming, and you know where to find us.